Hey, everybody, and welcome to this week's open demo for PV Farm. We are excited that you are here. While we're getting things going here, if you could drop in the chat where you're calling in from, what company you're working with, and your job title, that would be great information for us to know. And then I will, while y'all are doing that, we will work on getting some other questions together for you to make sure that we cover all of the right things in the demo today. But we appreciate you being here and your patience as we get started.
Welcome, everyone. Welcome to our PV Farm demo here. Thanks for joining, and yeah, we'll hop right into it. If you have any questions, feel free to drop them in the chat. But yeah, we'll kind of do an intro here of PV Farm and kind of run through, making our first layout and maybe touch on the a couple things kind of in the background here. So this is PV Farm. PV Farm is a web-based application for doing solar design, so nothing to download, nothing to install. That also means that you get our updates as soon as we issue them. We actually had a pretty significant update here on Monday, so kind of excited. Our team's really excited for that. We've made quite a few changes. But yeah, so within PV Farm, you can see kind of I've got this project here set up. I've imported a boundary, and then I've told PV Farm whether things are included or excluded. So to get started in PV Farm, we have the option to just import DXFs that are kind of your boundary, or KMLs, KMZs to kind of set up your project areas where you can build, where you can't build. We also have quite a few surface options available for folks that if you have a surface and you want to do some design, some grading, you can go ahead and bring your surface in as well. So this project's already set up. I've got some boundaries. You can see my surface kind of in the background here. And within my boundaries, I just tell PV Farm whether it's an included or an excluded boundary. So if it's included, then PV Farm knows that it can place equipment there. If it's set to excluded, then PV Farm knows to avoid it. So you don't have to process something like a buildable area. You don't have to process and tell PV Farm, hey, here's exactly where you can build. When you set those inclusions and exclusions, PV Farm is smart enough to know where to place modules once you run the layout. So really kind of helps you set things up a little easier there. So you just drag in your properties, drag in your boundaries, and then tell PV Farm whether it should be included or excluded. So I've got my surface in there as well. And with my surface, I can start to do some analysis on it. I can see, I've got my elevations of my surface. If I'd like to look at north-south slopes, for example, I can do that. If I'm curious about the east-west slopes as well, I can use some of the analysis there to start digging into my surface. I can also start to make other exclusions. So if I want to exclude certain slopes, I can create boundaries based on the north-south slope of my terrain. So I could say, for this project, I don't have any crazy slopes, but I could say, right, I want to create these boundaries at anything more than 2.5%. Negative is south-facing, positive is north-facing, and then I could create those as exclusion areas if I wanted to. So just a brief kind of rundown there of the surface. And then once we create cut fill, we can analyze it in the same way. PV Farm is a 3D BIM software, which means that everything we do is in 3D and everything has data along with it as well. So we have what's called the catalog. The catalog is every user's kind of basis of info, meaning that this is kind of all your equipment. So think of it as like your database of equipment. So we've got combiner boxes or LVDs. We have different inverters, different LV wire. If we have different trackers, different modules. If you have specific modules and tracker files for ONDs and PANs, you can also upload them straight into PV Farm, and PV Farm will create that equipment for you. Each company has its own catalog that's unique to your company, so there's no sharing, no fear of if other people don't have your equipment once you create them. So I'm going to go ahead and I'm just going to grab a tracker here and we'll place it inside of our project. So I've got this tracker now here in the project, right? In the tracker, right, I've got piles, I've got the tracker itself, the motor, the panels, and all of that has data that goes along with it. Right? As we mentioned, it's 3D BIM. So right, we can see here, here's the module, right? It's a JA module. Here's my wattage. I see all my kind of properties with it. If I'd like to make a new tracker, I can go ahead and make a new tracker and apply different modules to it. And you'll see that PVFARM is smart enough to know that, hey, you've got an error here. And so you need to change the tracker configuration, and it will help you change the tracker configuration as well. You can also start changing things like string counts. If you have different string counts, like I said, it'll give you warnings if you're creating objects that don't quite work. You can move things around within the scene as well. And so it gives you the ability to kind of go in there and really start tweaking your equipment to match exactly what you have. So if I have, for example, like I said, I can move that motor pile, longer strings, whatever it is. Once you're done with that equipment, then you can also save that to the catalog. And that equipment also becomes instantly available to any other user within your company. I also have the ability to go in and make highly detailed changes. So I can start to move piles around if I want. And what you'll see is dimensions of those things will also change as I start to kind of slide things around. And I can then change them manually over here as well. So really just highly configurable to make sure that you can build your real world equipment inside of PVFARM and then save it and use it on your projects. I'm going to go ahead and delete this tracker here. And we'll go back to our whole project. So we've set PVFARM up already, right? We've got the kind of this bigger area. We've got some exclusions. So now we just want to go ahead and make a layout. So the way PVFARM works is we have kind of 3 sections when we're making our layout. We have what trackers do you want to use, or what racking equipment do you want to use? What do you want your roads to look like? And how do you want your inverter configurations to break out that project? So for now, I've selected my tracker up here already, and I've got a next tracker. So we see the name, the next tracker, it's the Horizon, and it's using a First Solar Series 6 480 watt module. I can also add other configurations if I'd like, if I have other module wattages or other trackers, for example. For now, I'm just going to keep this. And what you'll see is these are all the available trackers that correspond to this model. So the first number here is the number of modules in a string, and the second is the total number of modules. So essentially different length rows. So for now, I'm going to go ahead and I'm just going to use my one row here, which is this 6 strings, 96 modules total. And you'll see PVFARM has told me the length. I'm going to go ahead and change my GCR. I could change it to whatever I want. I could also change the pitch. So I have the ability to do both. If I was interested in what the max, a specific DC target as well, I could put that in here. For now, I'm going to leave it as done, and I'm going to let PVFARM optimize the project for me and maximize the capacity on site. I can tell PVFARM I either want aligned or max capacity, what direction do I want my arrays. So I've got a tracker, so I'm going to run north-south. I have the ability for PVFARM to optimize the skew or shift. I'm going to leave that off for now and just set it to 0, but I can also tell PVFARM to optimize. PVFARM supports 2 types of roads, so we can either have our inverters and transformers running on east-west roads, or we can also have them running on north-south roads. Due to the geometry of the site kind of being longer in this east-west direction, I'm going to keep the east-west roads on. And I'm going to tell it I want it to generate equipment, or to generate roads, excuse me. And I'm going to tell it to ignore support roads. So support roads for us just mean roads that run perpendicular to the direction of our equipment access. I'm going to go down to blocking. I'm going to say, okay, I want a central inverter here. I could pick different sizes of inverters if I had a different inverter. So for now, I'm going to keep it at my 3.6 with my 3.6 transformer. If I had a different inverter that I'd loaded through an OND file, I could select that here. And I'm going to tell PVFARM what row height I want. I'm also going to say for now, I want roadside skids. So meaning I don't want a notch for my inverters to go. I want them all to be on the south as well. And then all I have to do is tell PVFARM to create that layout, and PVFARM will run based on the constraints that I've given it. So what trackers I've given it, how I've told it to create roads on site, and how I've told it to block the layout or to create electrical groupings based on my transformer and inverters. The other thing that PVFARM will obey is the setbacks that I've given it. So, what width roads do I want? Where do I want my equipment located off of the road? And then within my solar arrays as well, it's going to pick out which of the equipment is available to use. And then within that too, it's going to kind of keep my offsets constant here. So I've set it at 3 foot, but again, I could really pick any offset that I would like for it to run. I can also view, these are kind of the background of how PVFARM is going to use those constraints that I've given it. So right here's my clear distance here. I've got my row to row. Here's my block offset, array offset. So just kind of a rundown of what PVFARM uses as constraints to create that layout. So we'll see here on first pass, we made a layout that is 225 megawatts, and it's all blocked already because I told PVFARM I wanted it to block. So it created 54 blocks. You can see my AC-DC ratio here and my total DC capacity here. If I'm curious about what each inverter looks like as well, I can select this little item right beside my inverter. Oops, wrong button, sorry. Beside my inverter, and it'll give me the ILRs of every inverter on site that it's blocked out for me automatically. And if I'm curious, I can go take a look at that and say, hey, this is my lowest block here based on how PVFARM solved this project. If in future runs I'd like a tighter ILR, which I might not get as much capacity, I could have forced PVFARM to use a different range here as well when it's creating those blocks. So I've got 225 megawatts. I could also go out and say, I'd like to use a partial row. So I'm going to tell PVFARM it now has 2 row configurations. It has a 48 module row configuration and a 96 module row configuration. I'm going to tell PVFARM, let's update that and let's see what additional capacity we get, right? Meaning that we can now fill in some of those spaces that we had before. And now we're at a 242 megawatt layout. So we added about 20 megawatts there, right? And you can see where we've got some partials located now, because we've given PVFARM that option to now use that equipment on site. So now when PVFARM is solving the project, it has the opportunity to use those additional configurations to fit in some of the areas. I'll take a quick break here and see if anyone has any specific questions that they'd like to toss in the chat about kind of the layout or something maybe you're curious about. But yeah, you can go ahead and leave them in the chat and we will answer them as we go. But yeah, that's kind of our new layout panel. So within all of these as well, if I'm happy with the layout, I could also, if I'm happy where all of my equipment is placed, but I get a new inverter. Say I now want to do a 4.2 megawatt inverter. All I need to do is tell PVFARM, don't mess with the solar arrays, but I do want you to block, and I could change my block configuration then. So I could tell PVFARM, hey, I now want a 4.2. I'm going to change my transformer as well to something that matches. And now PVFARM will take all of the equipment that is existing on site, and it will re-block that layout so that it now has different inverters. So again, you could also change, if you wanted string inverters, you could do that. But the whole idea here is that PVFARM can take the layout that you have and reconfigure it based on new electrical equipment. This also means that if you have an existing layout in, say, AutoCAD and you want to import it into PVFARM, you can. PVFARM can take that existing layout inside of AutoCAD. We have some naming conventions, and you can just straight bring it into PVFARM, and PVFARM will recognize certain objects like transformers and boundaries and have the opportunity to then kind of reassign those to PVFARM objects. And then you can do all the things we're doing in PVFARM with a layout that wasn't necessarily created in PVFARM. So you can see it reallocated her down to 51 blocks, and you can see our blocks in general obviously have gotten bigger because we now have a bigger transformer. So really within PVFARM, we have the option to kind of use it to create our layouts from scratch. We can bring in layouts, we can run analysis, and then we can export out those items as well. As soon as I started placing all this equipment in here, I also start to get this energy report. So within PVFARM, we're calculating our own energy based on the equipment that you've placed in the model. So what modules do you have? What inverters do you have, right? We've got our energy model here to help you kind of find the ideal configuration, right? So as you start to run more and more layouts, you can look at things like, what happens if I change to a different module? How does that affect my energy? What if I change to a different GCR? How does that affect my energy? And start to let you in-app look at different energy generation between different configurations of your layout. Really trying to give you that flexibility for you to get as quickly as possible to what is the ideal configuration of your project, so you can find the best project possible as quickly as possible. So that energy is loading in there. And yeah, you can load your own media file as well. We have a synthetic point in here, but if you have a media file, you can load it here as well for your project, and PVFARM will use that weather data to generate the energy model for you. So low voltage, could be one of our next steps where we could jump to grading. For now, we're going to jump to low voltage, which is a pretty big update for us here at PVFARM. So low voltage, what you'll notice is we're kind of broken down into two pieces. So we've got low voltage equipment configuration, and we have wiring. So within the low voltage configuration, this is, how are we going to connect all of our panels to our inverter and transformer? So you'll see here, right, it's got this configuration. It tells me what inverter I picked, which is the inverter we changed to when we changed our layout. It'll also ask me some questions about, what factors do I want to use? What LVD do I want to use? Gives me some options on, do I want to keep a strictly straight configuration, or do I want to optimize them and try to fully load all of them? For now, I'm going to keep it kind of to the simple one, a little simpler on the wiring side. And then as I start to pick different options here, you'll notice that my graphics start to change. So, right, if I go clustered, you'll notice they change. If I do distributed, they change. If I change it to single array, you'll notice they're different, right? So all of those options, you'll start to get a preview of what that equipment will look like once you select it. So for now, I'm going to tell PVFARM I wanted to use this distributed combiner box or LBD, and I wanted to put it in the middle of the row, and I only want one row at a time to collect. Now I can jump down to wiring scheme. And what you'll notice in wiring scheme is going to show you now the wiring that's available. For this configuration, I only have one wiring scheme available, but if I had different configurations, others become available. But for central LBDs, I've got this extender to east-west trunk to LVD to DC feeder back to my skid. I have two options when it comes to sizing cable. I can either force PVFARM to use certain size cables. So say I know, for example, all my extenders are going to be number 8s, all my trunk bus is going to be 350, and I want all my DCs, feeders to be 600. I could force PVFARM to lay out using that configuration, or I could have PVFARM auto size the cables based on the voltage drop calculation. For now, I'm just going to keep it as custom and kind of force these wire sizes, and that's what PVFARM will use. And then we'll calculate a voltage drop based on the wires that you've selected. The other option you have when you're running low voltage is you can run low voltage on the whole project, or you can just run it on a portion of the project. And we do that by selecting different areas up here. So I've just selected everything, meaning that the low voltage is now going to run on the entire project. But if I had different configurations, say I want to use, central boxes on one portion of the project and clustered LBDs on another portion of the project, I have the option to then select different areas here. I can draw different sub areas if I'd like. I can force it to only do some boundaries or all the boundaries. Really, it's up to me on what makes the most sense for my project. So for this project, I've just told it to go ahead and I want you to generate everything. So, go ahead and generate all the low voltage for the other site, the whole site. So lay out all of my extenders, all my trunk bus, all my combiner box for everywhere on site. And that's what PVFARM is doing. It's now going through all of my blocks and it's looking at their configuration and saying, okay, how is the low voltage wire laid out on this portion of the project? It's going to lay out my combiner boxes or LVDs since I have disconnects here. It's going to lay out my extenders, and then it's going to route everything then back to my inverter so that I now kind of build out that collection of wiring on the project that makes up my low voltage. While that's loading, I just wanted to touch on one other thing here within our tracker objects. We also are carrying along, once we've kind of built out that tracker, we start to get energy from the tracker itself. So right, the tracker or PVFARM is calculating the energy, whether that's based on the media file or whether that's based on our media file, our synthetic point, or whether it's a point that you've loaded. The energy will start to calculate per tracker, and then that will roll up from tracker to combiner box to inverter to circuit to substation, and you'll get energy for the whole project. but it really starts at this individual tracker level. The other thing that we carry along is cost. So we're carrying along cost of each item within PVFARM. So you'll see the tracker itself costs a total of almost $36,000, and it's made up of the tracker frame itself, the module costs, and the piles. As you update grading and as you have different reveals, that pile cost will also update. And then you have the availability to have your own cost model. So that cost model isn't shared with any other users of PVFARM, but you have your own cost that you can input for these items, and you get a cost report for the whole project. So now we have cost and we have energy, so then we can get LCOE from that as well. So now we see our low voltage in here. And if I'm curious, I can take a more detailed look at it. And I could say, for example, I can tell it to now offset my wires, and that just kind of gives you the availability to look at them a little cleaner. So you'll see here's all my extenders up top. If I click on an individual wire, I can also get the information about it. So I can see this is a trunk bus, it's 350, and this one happens to have a 0.05% voltage drop along its length based on the wire that's been selected and the voltage in it as well. And then the last thing we'll kind of jump into here real quick. So yeah, I could change, if I wanted to change my configuration as well, I have that option to do. I can also, once I'm ready to export to CAD, I can go ahead and create groupings if I'd like. So I can say, hey, I'm curious and I'd like to create boundaries by hierarchy. And I have the option then I can do by combiner box here. I can do by inverter. If I want the whole block, I can create a boundary around the whole block. I can, if I see here where it's not joining my roads as well, I could change my offsets to then make sure I get a boundary around the whole block. For now, I'm just going to do combiner box. You'll see I get kind of a block around each or a boundary around each combiner box. So each of these trackers within this boundary is grouped to one combiner box. And if I colorize by, right now it's colorized by block. If I colorize by combiner box, then you'll see within each of these groupings, you get some repeat colors, but within these groupings, this is one combiner box, one. You can also export these to CAD. So when we export, we can export a DXF, and that DXF has our layout. We can export our layout with all of our boundaries in it. We can export our pile plan. We can export our wiring, our single line diagram, our terrain. All of those come out into AutoCAD in a DXF. For the single lines, on the inverter, or sorry, the transformer here, you can get a block by block single line diagram that has your single line, shows your cable size, and shows what it's connected to, all routing back to your inverter. And you get one of these in paper space for each of the blocks within your project. And then we also have a cost report running in the background. So as you're adding items to the project, you start to get costs that are associated with them. So we have a couple types of cost here. So we have cost of physical items in the model, and then we also have benchmark costs. So PVFARM knows that there should be medium voltage cable, but right now it's just put a benchmark cost at it. You can also change that benchmark cost if you would like, and it'll update the cost on the project for you. And once you're done with that, you can also export this out to Excel to create your BOM from there, because it has all of our quantities and costs in it as well. We also get our LCOE model here that kind of tells us, hey, based on the total project cost and then based on the generation, because we're running energy in the background, then we can get an LCOE number for our project. And again, these are all customizable, so you can start to change your costs, save those costs. You can even have different cost models if you'd like. To save them from project to project or from client to client. And yeah, that's kind of, I just wanted to leave a couple minutes here to see if anyone had any questions. So the costs are calculated based on items that are in the model. And the user can then input specific costs. So what you'll see here is for DC feeder, for example, you'll see that we have 600 kc mil. If I had other sizes, they would also show up under DC feeder. And I see I've got 1.1 million feet of that cable, and I just have a cost to it as well. So that gives me then a total cost. This cost PVFARM has stocked just as a starting point, But again, you can update it to be whatever you want from, once you have quotes back from vendors or from your partners, you can update those costs and then save them back to your model as well. And those costs will then update within the project and roll up within, now you're going to have, if I go to my overview, right, we have this electrical cost that will now change based on that. And we also then get $1 per watt cost. So you'll see I've got model-based costs and then benchmark costs. So as I design other things in the system, so once I click the MV button, I'll get MV, and that'll come along with the cost. And then I'll also have a single line diagram that covers the whole project. So those costs, can be updated based on whatever information you have. And then, you can change really any of the rates, anything kind of in blue here, you can change and overwrite. So for example, right, if we go to structural here, you'll see that I've got, my racking, right? It just assigned it because I haven't done the grading, but it said it's rigid trackers, and if I wanted to change the labor rates or the dollar per hour cost for those as well. So if I wanted to say, actually, these exteriors are more expensive to install, I could change all of those as well. And then all of those can be saved back to your model as well, and then be used in future projects. So, right, if I want to capture kind of the nuances of my project, I can enter those and then save them back as well. And you can have multiple cost models for different regions, different customers. If you have different EPC partners, you can have different cost models. If you have different regions you want cost models for, you can have those, and then you can just import them here in the import where you have this PVFARM cost. You can export out your cost report and then bring it into a different project. And your catalog, as soon as you save it, that catalog is company specific. So every company has their own catalog. And as soon as you save that catalog, it's instantly available for all other users within your company. So you don't have to, say, hey, go back to project Y and grab that tracker. That's what we're going to use on this project. That catalog is instantly available and it's yours. And once you have multiple versions within the same project too, not the catalog, but multiple versions, you can use our compare tool to compare them. So I've got a couple different preloaded versions here where I'm comparing different grading iterations. These first two are rigid trackers and these second two are terrain following. And I can start to look at the total costs and compare them directly to each other. Which helps me just to find, my best project, right? So I could say, hey, for this one, my best project is this one, right? It's my lowest cost, my lowest LCOE, even though, right, it might have more grading than some of the other options, the total cost is less. Because as we add additional trackers, as we add terrain following trackers, PVFARM is smart enough to know that those should cost more, so it adds a cost multiplier to the tracker equipment.
All right, I think that's about our time today. We appreciate everyone that joined. We did place a link down at the bottom of your screen for the 7-day free trial. If that's something that would be interesting for you, please click on that and we will reach out to get that set up and going. But again, we appreciate everyone jumping on and we look forward to working with you here in the future. Have a great day.